All right, I think, can you guys hear me properly here? Okay, awesome. I think I should get started here. So this talk going to be a little different than the usual other talks that you guys have attended. It's going to be much more light and relaxed because it's the last session. I don't want to really give you hard stuff here. But this is going to be completely talking about boundaries that we're going to cross. So I'm assuming lots of things. So let's quickly poll here. How many of you are actually working with Play right now? That's awesome. Perfect audience. What about Akka here? Okay, perfect. Okay. So this is actually based on recipes. So what is recipes here? In general, stuff that I've seen in the real world. So all the examples I'm going to show you here is some type of problems I've actually solved for some customer there. So these are all actually working or live in production, okay? And we're going to have a little bit of cooking theme here because I'm very fond of cooking channels. Food Network is probably my favorite channel. I love watching cooking shows. So we're going to build a 3-course meal here. Okay. The first thing I call is plaka. It's going to be a fresh plate 2.3 mixed with crunchy akka. Okay, that's going to be our appetizer. Then we're going to build a main course called plarim, which is going to be purely based on play. But we're going to mix in streaming to make it really juicy and tasty, okay? And finally, we're going to have a little bit of sweetness by mixing Slick to that. While I was bouncing this idea with my wife thought this would be a good idea to actually wear the apron here. So give it a real feeling that it's a cooking show. Hello, okay. The first problem we'll solve here is... let's look at this example while I tie this in. Okay, so example is what we're going to build here is, let's assume we are building a large multiplayer online gaming application. Okay? Now, what we have here is it'll build in something like this. We want redundancy. That's why we have, let's say, 3 versions of Play server running. And I have a little bit of proxy and which kind of routes those requests to Play. And when you build a Play application, first thing that you hear, what is the first thing that you hear? Your Play servers will not have any state in them. One of the beauty of Play application is they're completely stateless. Now, I am building a large-scale online gaming application. What that means is, whenever the user comes in, I want to represent a user somewhere in my application. And the challenge is, I'll talk about challenges here. The challenge is each user, as they are playing, they will accumulate some state, right? So what do you think is the best way to represent that in an application? So the normal tool that people reach out for when you have problems like this, now I feel really uncomfortable, is actors, okay? Actors is a great way to encapsulate this accumulated state that you're working on. Make sense? Okay? And the problem here is, if you look at this design one more time, when the requests are coming in, I don't have any sticky session. Okay? So I really don't know where the user is going to go in, where the request is going to land in which server. Why I do that? Because that allows me the flexibility of horizontal scaling. That's why we don't like sticky session. So my first challenge is, even if I try to model this with actors, let's say user comes in, for some reason that request lands up in that server. So actor will get created there. Then next request comes in, actor gets created there, and so forth. Okay? Now let's assume a scenario where user just changed the level. It went up in next level of the game. Okay? Now I need to update the state of an user. How can I do that? Because at this moment, I have a huge challenge. That is, I really don't know the location of the actor. Have anyone have solved this kind of problems before? Okay. So any ideas? Any ideas? I want to make this really interactive rather than me talking. Okay, just a thought. Yes, what else? So we need to do some sort of distributed caching, you're right. But actors is a very nice way to model this state, right? So if we can have something that allows me to have this location transparency so that I don't have to worry about it, and plus allows me to solve this problem, node crashes, right? Let's say I'm storing these actors in this, this system here. What if this particular node crashes? So all the actors that were accumulated state there, I had all the state in the memory. I'm going to lose them. So I need some sort of solution that kind of addresses all this problem. So the tool that we're going to use to solve this problem, we're going to do some live coding to actually solve this problem, is called Akka Sharding. Okay? So what's the problem? If I generalize the problem a little bit and forget about this online gaming, that is, I have these entities. I'm going to call each user actor as an entity. I have an entity set so large that I cannot fit in one memory anymore. So if you can imagine this large hierarchy of users in your application, and imagine you can take chunks of those subtrees, and deploy them in different servers, isn't that going to solve our problem? That's exactly what we want, right? Some large data set, like our users, that we cannot represent in one memory. So let's do some cooking time here. So let me walk through this code here a little bit. The first thing I have is a controller here, which has standard functions, simple functions, called create user, update user state, remove user. We basically need this three to demonstrate that it actually works, okay? And what this actions does internally is, like line number 18 or line number 23, it essentially calls some sort of actor and sends a message to that, okay? Now let's look at a user in our system. So user in our system is represented, like I said, as an actor, okay? And the mutable accumulator state I was talking about is right here, okay? This state gets accumulated, it's mutating, it's updating. And I have seen some standard messages here called login and logout. Login essentially means is that user come online, I'm just retrieving all the previous state and updating my actor with that. It's that simple as that. Okay, so first thing I'm going to do here, any question with this coding example before I jump into? Simple models, right? Okay, let's start. The first thing I'm going to do is that I'm going to create what my idea would be is that with Akka Sharding is that every node, if you remember the picture, every node I will create a proxy actor, let's call it a proxy actor, which will somehow know where each actor is running, essentially an abstraction, which will keep track of where each actor is running in a cluster of nodes, okay? There is a nice extension called cluster sharding that I'm going to use here. So first thing I'm going to do is go to my global class. Hold on one sec. I should have been more prepared. Give me one sec here. All right. So I'm going to go to my empty global now. It should be empty. Let's create a global callback for play. I don't know how to create a file. Thank you, yes. All right, this is standard play at global. Let's put a package here called global, just in case. And this guy will extend, what it will extend? Global settings. That comes with play out of the box. I'm going to do the API one since we are working on Scala here. There will be an on start that I need to override and on stop. It's always a good idea to put override, by the way. So time to time, I'll say some Scala best practices as well. So it's going to take an application, which will be our play API application. So far, so good. First thing I'm going to do is that every time a play app starts, what happens? excuse me, the onStart gets invoked. When the onStart gets invoked, the first thing I'm going to do is that let's create a private this var. Let's call it system, which will be an option of actor system. Okay. For now, it's none. So when application start, I need that application start because I have some clustered configuration. I'm going to show you what is that configuration. But for now, I'm just going to take this and just create an option of actor system. And we're going to call that cluster system, let's say. Okay. Now, once the system is started, the first thing I'm going to do is that start my shard. So every node will have that proxy shard I was talking about. Okay. So I'll say system for each create shard. And finally, on stop, what I'm going to do is stop the application, stop the actor system. So I can take system dot for each underscore dot shutdown. Okay. Let's look at this create shard because that's an interesting one. So I'm going to say create shard, and it will take the actor system as a parameter. Okay. So the thing that I'm going to use here, let me know if the code is not visible. Okay, I'll move it up. Is use this cluster sharding. It comes with an external dependency. Okay. Cluster sharding as an apply method, we take the actor system. I'll pass that actor system. Then I call something called start. Okay. I don't remember what starts take. So let me copy all the stuff here. Okay. Which one I want? Yes. Thank you very much. I cannot type in one hand. All right, so let me copy this. Is it better? Okay, so go back to my app global here. I'm going to paste it. And let's walk through a little bit of what each of this is. So when you're creating a shard, remember each node can have multiple shards. Here I'm creating shards of users. It could be shards of accounts. It should be shard of your guests, whatever, okay, entities you have. So the type name will come, let's say type name, we'll say for this shard will come from our user actor. User actor will have something called shard name. We will fill that in. It's called user, isn't it? Oh, joys of life coding. Actors, there you go. Okay. So we'll say import this little bit here. Okay, so shard name. What is the shard name? It could be any string, okay? Just some unique identifier that identifies the shard. So shard name is, let's call that users. Now, next thing I'm going to do is that entry props. Remember one thing, that means the shard needs to know when the request comes in, how can I create this entity for you? How can I create this actor? So that information is passed right here. We'll say, hey, use sum of this user has already a props method, use that. Okay? Next, we need to build something called ID Extractor. I'll talk about that a little bit. Let me fill this in here. And finally, shard resolver. Please ask me questions, okay? All right, let's go back to the user here. What is ID resolver? I need to take the type. So ID resolver is So for an example, when a message comes in, okay, how will the shard know how to redirect that message? So when I design this messages, if you have noticed, all the messages extend a trait called user message. So user message has a unique identifier called user ID. So when a message comes into the shard, it looks at, wait a minute, can you give me an unique identifier for this message so that I know where I should route this to, okay? So that could be anything. So it's essentially a function. So I'll say case. I will say case any message, user message. If that comes in, it expects this ID extractor is nothing but a alias for a partial functions. Remember what's returning is for any message, an unique identifier and a message. Give me a tuple back so that I know how to route this. So I know that already, which is my my user ID and my message. Next one is a little tricky. Next one is saying, wait a minute, what is shard end of the day? Shard end of the day is a group, okay? Group. Now, you could have 100 user actors or thousands. Can you please tell me how should I break them into groups? What is that strategy? How can I shard it? How can I partition it? That's what the shard resolver will do it. For in this case, we'll just be naive. I'll just select something stupid example here, okay? So again, any message, user message, I will say all it's going to do is take the hash code of that message, modulo that with 100, and just make it to string. Okay? You can override this. You can have your own allocation strategy if you want to. Good call, thanks. All right, so we have, if you now go back to our app global here, what we have is that every time an application starting up, it's also starting the sharding component. Okay? Now comes the interesting part. Wait a minute, now when I go to my controller looks at this game controller, which is essentially another actor. Let's create this actor. So I will go app global dot system. I didn't expose the system yet, have I? So let me do this here. Get or else throw new runtime exception. You are screwed. Okay, so I have a system. I hope I'm not screwed here. So I have a system here, app global. What's going on here? And app global has a system method here, where I can say system actor off. I'm creating an instance of this actor. How will I create this instance? I will go to my game controller, and I say props. Yes, thank you. What's going on? Who can help me with this app global not working? I thought Scala solved that problem for us. Let's try that. I made it class. I haven't. I know that will bite me, but let's not worry about that right now. Okay, so so I have a game controller. Obviously, we are good city. Again, another interesting pattern. A side note, it will help you. Remember, whenever I'm doing props, this is a very common pattern. You should define your props in the companion object, not in the class, not in the outside. This is a very standard practice. So I'm going to have, let's say, game controller here. Okay? Now the question is, I send message to my game controller, so the message comes in. So let's look at the picture here. Can I go back to slide quickly? And let's look at this picture here for a second. Let's say I'm looking for this green actor, okay? But for some reason, the update message ends up with this server where the red actor is running, okay? And controller creates that message, sends it to the game controller. Now game controller has to figure things out. It is, wait a minute. I need to know whether that actor is running locally in my node or some other node in the cluster. For that, if you go to the game controller here, I'm going to do an interesting thing. I'm not going to create just another actor. This region, this is an actor which will be a special kind of actor. How can I create that? Again, I'm going to reach out to my cluster sharding. Okay? And cluster sharding again takes an actor system. I'm inside the actor now, so I can do context.system. Now, then I would say, give me a shard region. Okay, this will create an actor for me. For which shard you want this region? For that case, I'm again going to use my shard name. If I have done things correctly, this is all I need to do to make this whole application work. I don't need to know where my actor is running. I will be able to accumulate state. I will be able to do all the location transparency I want. So let's try this out. Before we try, I want to show you my application conf file, because I think it's going to be important. So I have my play application conf file, but in this, I have added my cluster configuration. So what does this configuration looks like? I'm saying my provider will be cluster actor ref, and my cluster seed nodes will have 2 seed nodes, which are going to be running on 2551 and 2552. Okay, seed nodes are not your leader. Okay, this is a starting point. You want to start a cluster? Just tell me what will be your initial contact points. Okay, these are not leaders. So I'm going to go to my README file here. So my target is to do is I'm going to start 3 servers, play servers, and try to send requests and see what happens. Thank you very much. Hold on to that question. I'll be back. I'm here. I will be able to answer the question. I'll be back. Yes. Good call. Thank you. So I'm going to do activator, not there, and another activator. I need 3 what I am doing, and another terminal activator. Something weird happening. I'm not in the right folder. It's end of the active. You're killing me. This is a great way to see how one struggles, okay? Look at me like this. All right, activator. That was a very good advice. Thank you very much. Activator. I usually do better than this, though. Usually. Activator. Okay, so I should be having 3 prompts soon here. Okay, so I'm going to go to my README file a little bit here and run the first play server. Let's understand what's happening here. I'm trying to run the first play server on port number 9001. That's a play server. That's my HTTP port. And the next one is Akka remote NAT TCP port, where the cluster is going to communicate. Okay? I need to have something running on 25501 and 2552, remember, because I've configured that in my application conf file. Similarly here, but this time I'm going to run on 3. Okay. Now, I'm running in dev mode. That means it's going to be lazily initialized. I want my cluster to be created. So I'm going to just warm this up a little bit. So what I'm going to do here is that I'm going to call my index action on each of the ports just to make sure they warm up. Yep, thank you.
Can we have a look at the application of sorry, there's another file. I don't remember which one. We have an option instead of a song somewhere in there. No, it's fine. Okay.
Any questions while I struggle? Okay, so it's up. I'll try to refresh it again. Yes, please. Where are you? Okay, yes. Good question. No, I think it just expects int or ID, some sort of ID now. I don't think there is a constraint. All right, so lots of chatting going on right now. Let me quickly start the 2 here as well, so they can form a cluster quickly. So yeah, so lots of interesting stats happening. I'll do for 3 now. So at this point, we should have a cluster with 3 nodes. Okay. Now, what I'm going to do here to test this whole magical location transfer, I can go any node work, is I'm going to use Carl here. But before do that, let's check out the routes file so that we understand what exactly I'm doing. So if you go to our routes file here, so what I have here is that I have a put method. It should be put, which actually creates an user, and then I have a post, which actually updates the user. So my goal would be I will fire put to 9001, let's say, assuming the actor gets created there. Then I'm going to do the post on some different node, send the request to a different node, and see whether it can figures out where the actor is running and update that actor state. I will rely on readme again here. Okay, so I have this curl command. So it says user is created. So if I go to this node here, you will see there is a message called new user created. Okay, this is on the node 2551. Okay, and it kind of makes sense one way, because if you look at my curl command here, I am sending the request to 9001. Okay. Now I'm going to do a different thing here just to make sure this works. I'm going to fire an update. But when I'm going to fire an update, okay, I have done in 9003, okay, a different server altogether. So any message here? No. But if you look at that, that server was able to figure out where the actor is running and actually applied that delta changes. Only with 15 lines of code and lots of struggling, I was able to manage this. Any questions?
Yeah, still a good idea to have the load balancer apply sticky sessions to
No, it's not. Now, one question I was expecting, though, which I didn't do because obviously for the time constraint, is look at the state thing with a huge comment out there, right? So this actor has accumulated state. I don't know how many of you have seen the Akka persistent presentation. So this is not a bulletproof solution yet to make it really consistent and and recover from node crashes, you need to implement Akka persistence here. What I have in my challenges, I had 3 points. I've only solved 2 of them. The node crashes has not been solved yet. For that, you need to make sure, for an example, the game state change, line number 25, this is something you all care about. This is something updating a state of a user. You need to make sure this event is persisted somewhere to really have a fail-safe way to do it. Now, this beauty, there are lots of advantages. I mean, I wish I had more time to talk about Akka Sharding because I think it's very cool, is there are allocation strategies. It will reallocate based on you're going to balance your groups once it figures out that, OK, there is a node out there which has less number of actors. Let me rebalance, move actor instances to different node to balance out. It's all going to be happen behind the scenes for you. Yes? Because it's faster. Yeah, I mean, because it's going to affect your throughput and latency if you start doing thinking about that stuff.
Can you repeat the question?
Sorry. Yes, I should have. I'm sorry. The question is why have a state inside the actor? Why not just persist it in the database? So the answer is this is faster way to do it. Right? I mean, it's just a very interesting change happening. I don't know whether, because hardwares are becoming cheap and our resources are getting easier. So there are machines out there with lots of RAMs, lots of memories, right? So now, instead where we used to build applications where we used to read all the records, let's say we have account information in the database. We used to read all the account information of persistent storage. Now, with the sharding and clustering, I could have my whole database read into memory and represented as actor in my cluster. So if you imagine that possibility, I'm just giving you a possibility where each row is represented as an actor and it's in memory somewhere. So there is a tractor company in US for which I proposed this sharding solution. I can't give you the name, I'm sorry. I have lots of, yes, last question.
I know each shard is defined in your application.conf file.
Yes.
Now let's say you're like in a cloud computing environment where you want to spin up another 5 nodes, but you don't know, ahead of time you don't know IPs or anything for them. How would you
There, yes. The question is, I have, if you look at my application conf file, I have hard-coded my IP addresses there for seed nodes. Now, the question is, this is just for seed nodes. Remember, you can dynamically scale. This is elastic. You can add more nodes to the cluster. You can take nodes down. But for them, you don't have to. I didn't specify IP addresses for all the machines. All I did only for seed nodes. That also programmatically possible if you don't care about that. So Akka cluster needs some starting point. Again, it's not a leader, some starting point. Can I go to the next recipe and then questions? Okay, thanks. What is that sound? So recap, it's a great, cool thing to work with. Okay, so move on. So we want to build our main dish here. I'm already feeling hungry, very much hungry. I want to have this juicy steak right now. So what problem we are solving here? Now, this is very interesting. This is one I can publicly talk about because I did this for LinkedIn. Okay, so they're rewriting their homepage. Okay. Now, challenge is if you imagine this is a LinkedIn homepage, what's happening here? We have these boxes. Okay. Each of these boxes could be who viewed my profile, jobs I'm interested, right, and your feed. So what essentially happens when you have this kind of applications or new application architecture designed these days is when you have this kind of thing, this is exactly what it looks like behind the scene. A request is going to come in, let's say /home or linkedin.com. It gets handled to some sort of controller. And what this controller does is that takes a request and fans out to multiple services. You can imagine each service being, this service being who viewed my profile. Its only job is to fill up one box in the UI. Okay? Okay? Now, what happens here? Now, since we are invoking all these services, each service has a different performance characteristics, right? So when I invoke this application, what's happening here is that I will send all this request all these services, even though I'm doing asynchronously. I'm just simply can't do. I'm simply cannot send anything back to my client unless all of the services return. Make sense? While all of this returns, then I finally send the response back to my user. This is a very traditional way we do things. Now, what are the challenges? Now, over and over, studies has been done that reducing time to first byte is very important. What does that mean? That means is that I, as a user, typed in nilanjan.com. And by the time I hit enter and the time I see something happening in my page, that reducing that time really matters. And we talk to companies like Amazon's and all that, they always look out for that. Because chances are, if I start showing you, even if some empty boxes, you will likely to stick around to see things happening. Now, the problem with this is now I have this situation where different services have different requirement. How can I address that problem? Wouldn't it be nice if, as when a service finishes, I immediately send the response back to the user? Okay. Now, obviously, the one common thing that people think about here is, Nilanjan, why can't you use Ajax? Who thinks they can solve this problem with Ajax? I think we can solve this problem with Ajax. But what's the problem? What would be the cost if you use Ajax to implement this problem or solve this problem? Typically, in browsers, Ajax is the lowest priority thread. That's the last thing browser is going to try to do after it downloaded all the scripts, all the CSS, and all the resources. Now, imagine this. If you go back to my diagram here, well, I have this. I should use this technology. It could so happen that one of the services here is really slow because maybe it's doing some data mining to come up with fill up a box which is only meant for you. Okay? Now imagine using Ajax. That means if I use Ajax, what's going to happen? You send me a request, I give you immediately a page back with all my markups. But all my divs or spans or whatever will be empty. Then I'm expecting some JavaScript code to kick in here and then invoke all these services using Ajax. Now, let's say this service is slow. Ideally, when you have a slow service, that's the first service you want to invoke. So while it's processing, you can do other stuff. Now, since Ajax is the last thing that browser will try to do, the service that's already slow, you're invoking on the low priority thread is actually going to increase your latency further down. That's really not an applicable solution at all. So are we screwed? No, we are not, right? So it turns out Facebook, out of all the companies out there, Facebook actually doing some interesting stuff. They have something called BigPike. You probably have seen this presentation by Jim before. That's exactly what we did. And trust me, it took actually a couple of hours to solve this problem in play. And I'll try to do that in 15 minutes here and see how that works. So the solutions we're going to implement here is that as when the request comes in, service finishes, I'm going to send those packets back. There is something in HTTP you can use to actually solve this problem. It's called HTTP chunking. Okay? Now, what's the benefit of this? Remember, the benefit is that as when you're sending a request, I'm immediately sending you the data back. Okay? What is the data content? So far, the data will have just the head element. Okay? What with all the stuff, what will be inside? Will be some script tag and CSS. So by the time I am processing and I chunked you already data, browser is saying, oh, I have script tag. I better start downloading. I achieved parallelism. While my services are busy doing, there a browser will say, let me download the CSS for time being. Right? This is an excellent approach to do this. All right, get back to cooking time. I need to switch back again to a project. Any questions while I try to do this? questions? What's going on? Right here? Thank you. Okay, let me check this out here and go to a project. So I have this the structure here. Let's look at the structure. I want to open the application first. Oh, there is a file caller. Okay. Let's look at that. So this is exactly the picture I'm trying to do, okay? So I created my own social network site. I mean, why not, right? So what people are saying about me, I'm more interested. Services you might be, okay, stuff like that. So what's happening when an index action, which could be a /home, gets requested, I invoke all the services, okay? So these are essentially a service. What each service is doing, let's look at them. So essentially, I have a simple base interface here. So it's supposed to come up with feature of HTML. End of the day, what the service is trying to do, come up with some HTML data for me, okay, asynchronously. Now, the first thing I need to do here is that obviously this OK thing is not going to work. Why it's not going to work? Because OK is going to do the traditional way, which is wait for all the requests to come in, finish, then start streaming the first byte, which we don't want to do, okay? For this, we're going to use a tool inside a play called enumerator. Enumerator is an abstraction for streaming data. It represents a data stream, okay? Now, if you have used, how many of you use Scala templates in play? Or Twirl templates now, okay? So if you look at the templates, the way the templates are designed, it says index.scala.html. Okay? So HTML essentially determines that what kind of templating language that I'm using here, okay? Or what will be the output for that. In this case, what we have done, especially for LinkedIn also, is no, that's not going to work for me. Why? Because when I'm going to build my page, HTML, head, body, inside the body, what will I have? I will have a group of stream. I don't have markups. I have a stream object. So by default, the Scala .html template doesn't understand that. For that, we have created something called pagelet. This is my own format, let's say, but which is exactly like Scala HTML. So this also shows the powerful nature of play, how we can easily do that. To introduce a new template type, all I have to do is come up with this two things. First thing is called template formats. Okay, I'm creating my new format here. I'm saying, hey, any file that ends with pagelet, I know your default Scala compiler, the template compiler will not understand this, so send it to me. I know how to deal with this. That's exactly what the setting is doing. And the next thing is essentially to make my life easier, I am adding a template imports. What that means is that when that Scala file behind the scene will generate it, those packages will automatically get imported for you. Okay, that's it. Now let's go back and try to implement this pagelet format. So to do a pagelet, you need to extend this something called format. Twirl. What am I missing here? Format, right? Yeah. So format, which takes some type, which is a subtype of appendable. So I'm going to create a type here called, hey, format should take pagelet. I don't know that type yet, so let me create this. So I'll have a class called pagelet. I don't know what that class will take yet, but I'm going to have that extend appendable, which is also pagelet. Okay? I wish they changed this name here. Okay? Now format is obviously abstract, so this is also a very interesting way to know what exactly happened behind the scene how play parses the template. So I'm going to do this thing here and implement all the methods. Okay, there's only 4 methods that I need to implement. First thing I need to implement is a raw here, which I'm going to do that saying, let's call it HTML for now. So I'm going to say new page let, which I'm going to use HTML format, just take some help, and invoke its raw method. By the way, it needs to be an object. Okay, so it's a similar pattern. Same goes for escape here. Bless you. Let's hold on to the next one because the next one is very interesting here. What's going on? Okay, all right. So what I need to do here is take each of these modules that coming up with and convert them to pagelets. So pagelet will be my abstraction for a stream. Okay, I'm going to build an abstraction of a stream so that I can take that stream and give it to my template language and say, just put it in somewhere in the file. Okay? Now remember what I am doing here, I want to achieve this. If you look at my index file here, I don't know whether you guys are getting excited like I am, but I am passing a pagelet here, which is an abstraction, something that I can touch and feel, okay? But it is a data stream. And I'm putting it right there inside my template. So if everything works, what's going to happen, let's visualize that. Probably that will help what's going on here. Is when I'm going to return this page, I don't know how, I will figure that out, is since all of this are already defined, I have this stream, all of this data will immediately be streamed back to the client. Okay, browser will get my stuff. And here, browser will say, wait a minute, I have an enumeration of data. Unless the data arrives, I'm not going to do anything. So it's going to wait there. Now, every time a module finishes, it's going to start streaming data. That's exactly what I'm trying to achieve here. So I'm going to take each module here, and I'm going to interleave. This is probably the most interesting method we're going to implement for this recipe. 3 lines of code. Okay? Why interleave? Why we do that? Because remember, I don't have any control over when this module, each of this module will finish. So I am combining them into one stream where whenever someone has a data, I'm going to send that data back. Okay? It's as if you can think of as a pipe where 4 people trying to pour things up, whichever comes, whichever goes, it will go there. I have no control over that. There is no ordering here. There is no sequencing here. Okay? So what I have here is that I'm going to do for expression here. So I'm going to say for each module that comes in from these modules, okay, I'm going to convert that to an enumerator because that's what Scala, that's what Play understands. What it will have? It will have an HTML. So I'm going to say, oh, this is going to be an enumerator of HTML. Can anyone tell me what is the type of this? What is this type of this enumerator? Let's call it E. I want to check how many people are following here. So module is what? Scala programmers. Future of enumerator. Okay? So I need to do yield here. And what I'm going to yield, I'm going to use, that I don't want. I want enumerator, not future of enumerator. So I need something that can flatten this structure for me. So I'm going to use an enumerator. There is something called flatten, which takes future of enumerator. So I'm just going to pass E here. Okay? So what I have is a sequence of enumerators at the end of the day. Then I will use this magical method defined in the enumerator library called interleave. And I'm going to pass all my enumerators. Okay? But since I need to convert this to a pagelet, I need to figure out some way to pass this as a pagelet so that my format can understand. Okay? So I go to the pagelet here. Let's have an apply method, which takes an enumerator. Oh, let's do other way around, sorry. Trust me. Okay. All right. So I can go back to my application here now, and application I said. Isn't there an IntelliJ booth here? I better talk to them. Okay. So I have this. I'm just going to say new pagelet here. Okay. And so this is going to return a pagelet that I can just pass it to my template. Okay, all right. So at this point, I have a pagelet which combines all these streams together. All I need to do now is say OK.chunked views dot pagelet.index all modules. Okay, and I need to figure out how to do. Is that called HTML? Now, if you look at this, let's see whether this works. If you look at my modules here, I have explicitly put some delays here, like 2 seconds, 1 second, 500 milliseconds. So let's actually change this to 4 seconds so that we can see some differences. Okay? So what's going to... You guys are so great. Thanks. Okay, so let's look at this index a little bit here. So what I have here is, I have these divs, 4 of them are empty. When I send this page, all the content till end of the div will get streamed to the user, to the browser. And this modules is an interleave of all the enumerators. So as when the feature completes of each of this, data will be chunked to the browser. The data that way I'm chunking is I think it's better to understand this. What's happening is I'm wrapping this to a module. What it's doing, so all the chunk that I'm sending essentially has this piece in, where it takes the data, executes this inline JavaScript to take the content and embed just within that div. Making sense? Okay. All right. Let's do this. All right. Actually, I heard it's very easy to get rid of that white space delimitation in SBD. Okay. You should convince SBD guys to do that. Okay. All right. Then let's go back here. So what I'm going to do here is that if things are working, we should see some boxes appearing and some of them appearing at late. I have no idea what's going to happen. Let's see. That's a lovely picture, though, by the way. Don't you guys love statically typed languages and this nice little errors that Play gives you? Okay, the reason it's failing is this method right here that we have left with triple question mark. Okay, what is this method? So when you do pagelets, what's happening is that the compiler is taking that template page and breaking into multiple chunks. And is giving you an option saying, hey, I have this sequence of pagelets. You better tell me how should I compose them together into one page so that I can render it back. You have to tell me. So each pagelet is also an enumerator, right? So how can we do that, guys? What is the tool we reach out for? From many to value, if you have to reduce a value. In today's keynote, I was talking about that, fold, right? Or we can do reduce here. Let's do reduce. It's going to be probably simple. Okay, so we're going to do reduce here, reduce. Okay, so reduce take a function, right, 2-parameter function. So what we're going to do, each one will be a pagelet. So we're going to say HTML, and enumerator has a combinator called and then. Okay, this is not the streams. This is the page sections that I'm sequencing. You better send the start of head element there before you send the end of head element, right? HTML is a markup language. It has a sequence. So we need to sequence this here. What? Thank you. So let's try this one more time here. What's going on? Let's step back here. So I have a sequence of pagelets here, right? So I have a sequence of pagelet. Let me do this, simplify this a little bit. HTML, so I'm going to have enumerators now. Then I can call reduce on them. So do and then with another one, right? And finally, whatever I will have, I can do a new pagelet. So as you can see, as when the data is arriving, I already have this. So this is It also makes a lot of interesting things that you can view here. Like as I'm processing, you look at that, a browser has already started downloading if you do a network time here. So it's actually overall reducing the time for your page. Any questions? Am I out of time already? Okay, yes.
How do you do cookies and such?
There is a way in HTTP chunking you can pass trailing headers. So there's a possible way to do that. Okay. Yes. So the question is, are you doing all this chunking? Is there how can we pass cookies and other information, header elements like that? Now, if you look at HTTP chunking spec, there is a way of passing trailing headers. It's actually easy to do that in Play as well. Play has a support for trailing headers. So as you're sending a chunk, you can actually, it's a very interesting use case because some of these responses could be JSON, sometimes it could be a markup, right? How can you specify a header? We use HTTP header to specify the content type. You can still do that with each chunk. So I guess I'm already chopped now because I didn't finish all my dishes. So I did have a dessert, but I guess we don't have time for this. But if you guys are interested, this was about Slick. I did mention Slick. I was thinking of talking about Slick, but later on if you guys are interested. Because this was mainly about doing circuit breakers, how you handle blocking calls. So the code is right here in this repo. I've just uploaded this. So thank you very much.